this is a standard form, and this is what I was telling you, how I do the x-intercept and the y-intercept. I let x be 0, and when x is 0, whatever is multiplied disappears. So I have 2y equals 3, or 2y equals 6. So I have 0 for x, y is 3. I know that point. So I'm going to go right there. Then, I guess tiny pinky, I have 3x equals 6. When y is 0, 3x equals 6, so x equals 2. And then I come over to 2, and now I can do my line. That's graphing my x and y intercept. And notice I did not do something before I started, which I would have messed up this problem. This is a dotted line. So I need to come in here and I need to erase and make this a dotted line. Okay, so I'm going to erase it and come, see, and make it a dotted line. Okay, and then I'm going to do my test point. If I put a 0, and this is definitely on one side of the line or the other, so I'm going to put 0 and 0 here, so 0 times 3, so 3 times 0 plus 2 times 0. That 0 is greater than 6. Is 0 greater than 6? No. So no is not colored. And then you come across the line and color on the other side of the line. Your test points make it extremely easy to figure out what side of the line you're going to do. Okay, here we go. Another standard form inequality. I'm going to have x, when y is 0, x is negative 6. When x is 0, and I don't cover up that, and so you have negative 3y is greater than or equal to negative 6. I do it as an equality to graph, and then change it back into an inequality. So if I have negative 3y equal to negative 6, then y is 2. That just gave me 2 points on my graph, and I have that point, the x-intercept, I have the y-intercept. I then have to pay attention that this is solid because of the underline. I'm going to state it. I'm going to make a solid line connecting the 2 points. Didn't do that very well. Okay, 0 is my test point. I say 0 minus 3 times 0. I get 0 is greater than negative 6. 0 is greater than negative 6, so he needs to be in the shade, and everything needs to be in the shade down here. So when I grade these, I am looking for specific points that fit the line. I'm looking whether they are a solid line or a dotted line, and they're appropriate, and the correct side of the line is graphed. Okay. Y is greater than 3. We know that y is a horizontal line. We know we do it at 3. We know that this is going to be dotted because there's no line under the inequality. I'm going to do this. Y is greater than 3. That means up here, because if y was 4, that'd be true. If you still want to use 0, 0, you say 0 is greater than 3, no, and no is never in color. X is less than or equal to negative 4. We know that that is a vertical line at negative 4. We know that this is solid because there's an underline under the inequality. I do my test point of 0. 0 is less than -4. That is a no. That means no color. Go to the other side of the line and color. Anything in the color is true. Anything in the not color is false. Okay, which of the following points would be a solution to the inequality? And I'm going to, since if I did this in standard form and I would get fractions, I'm going to go ahead and change it into slope-intercept. I'm going to subtract 3x. I'm going to subtract 3x. I get -y is greater than -2 minus 3x. In order to graph, I need just a positive y. So if I have a -y, I'm going to divide everything by -y. But as I divide, I'm also going to flip the inequality. So y is less than 2 plus 3x. Putting it in slope-intercept, y is less than 3x plus 2. I then have a y-intercept of 2. And I go 1, 2, 3 up and 1 right. And 1 right. Okay. No underline in the inequality. Therefore, it is dashed. I do my test point back to the original. 3 times 0 minus 0. That 0 is greater than -2, which is true. 0 is right here, so this side gets colored. Then we go look for points. -2, 0. Is he in the shade? He's not in the shade. He's in the non-colored. That is false. He is not a solution. 4, 8. There's my point. He's in the shade. That is a solution. 0, 2. Right there. It's your y-intercept. However, he is not a solution because, and that's a no, he's not a solution because he sits on a dotted line, and dotted lines are not included in your solutions. So let's put it another way. If this was a solid line, that would be a yes. Because it's a dotted line, that is a no. So things on a solid line are solutions. Points on a dashed line are not solutions.